an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft.
On July 1, 2025, NASA confirmed the third-ever interstellar object, 3I Atlas, racing through our solar system, brighter and stranger than anything seen before. Anomalies in its orbit and chemistry forced scientists to upload every fragment of data into the world's most advanced quantum AI, and when the simulation finished, the results were so disturbing that some researchers are still struggling to process what they imply about Atlas's purpose. The numbers hinted at the unthinkable, an engineered visitor on a deliberate path, exposing vulnerabilities humanity never imagined. The discovery began when the Atlas telescope in Chile's Rio Hurridu Valley flagged a faint point of light, magnitude 18, just above the galactic plane in Serpens Cauda. At first, it looked like another minor planet, but its steep motion across the starfield didn't fit. Within hours, the Minor Planet Center had given it a temporary code, and by the next morning, observations from 3 continents confirmed the same truth: this was no ordinary comet. Its trajectory was hyperbolic, with an eccentricity over 6.2, shattering previous records, and its speed, 58 kilometers per second, was more than twice that of typical asteroids. Officially designated 3I Atlas, it became the largest interstellar visitor ever detected, its brightness already outpacing expectations at $4.50. Unlike most comets from the Oort cloud, Atlas traced a nearly straight line through the solar system, its path pointing back toward the thick disk of the Milky Way, hinting at an object older than our Sun. The odds of such a trajectory, so precisely aligned with the ecliptic, were less than 1 in 500, and its close approaches to Mars, Venus, and Jupiter seemed almost too exact to be coincidence. Even stranger, the object's brightness and coma defied natural models, forcing scientists to abandon classical computing methods that unraveled under the weight of so many anomalies. Only quantum AI could map the entire landscape of possibilities, modeling every trajectory, every chemical reaction, and even faint hints of non-natural behavior at once. When NASA's Quantum AI Lab finally ran the simulation, the results only deepened the mystery. On August 12, James Webb locked onto Atlas's coma and found carbon dioxide outpacing water vapor by a staggering 8:1, venting in timed pulses that matched the object's 16.8-hour rotation. Instead of random sublimation, the gas behaved like controlled bursts, more like pressure valves than melting ice. The ratios didn't match any known comet family, and the fine dust grains released were too small for natural outgassing. Quietly, in lab meetings, the term artificial modulation began to surface. The quantum AI flagged the emission patterns as statistically closer to engineered venting than natural sublimation, raising the unsettling possibility that Atlas was steering itself using its own mass loss. If true, the question was no longer what Atlas was, but who, or what, was guiding it. The high-resolution images only added fuel to the fire, showing a tail structure that looked less like a snowball in space and more like something designed. The shape, the sudden brightness, even the direction of the outflow all looked less like passive outgassing and more like a jet, or the exhaust plume from a controlled burn. That's not how comets are supposed to behave. Normally, material drifts away in a broad, diffuse fan, but in the case of 3I Atlas the ejected gas and dust formed a tight, focused column, almost like exhaust from a nozzle. The venting wasn't steady, either. It pulsed in rhythm with the object's 16.8-hour rotation period, each burst tied to a specific longitude on its surface. Every time that point rotated into sunlight, the tail flared to life before snapping back into silence. Spectroscopy added another layer of unease. The tail was rich in carbon dioxide, but also carried an unexpected metallic signature. Instruments detected nickel with almost no iron, an imbalance nearly impossible in natural bodies since nickel and iron are usually forged together in stellar furnaces. Some researchers began to suspect the tail wasn't just vaporized rock. Nickel, after all, is a key component in high-temperature alloys used for heat shields and turbine blades. If Atlas's tail contained nickel-rich exhaust, it might suggest a propulsion process. Using metal as a working fluid. The quantum AI flagged the tail dynamics as distinct from every comet in its dataset. The venting wasn't random, it was coordinated, as though the object were steering itself. Simulations confirmed that if the pulses were timed correctly, Atlas could nudge its trajectory by small but deliberate amounts, like a swimmer kicking off a wall. Theorists began talking, hesitantly, about plasma exhaust, about the possibility of an object using controlled venting as thrusters. If true, it would mean the tail wasn't just debris, but a tool of propulsion. And that raised the unsettling possibility that Atlas was moving with purpose. Trajectory analysts at NASA's Jet Propulsion Laboratory soon uncovered more anomalies. Updated orbital integrations showed Atlas was on course for a series of near-planet flybys. Mars at just 28.96 million kilometers on October 3, 2025, then Venus 4 weeks later at 97.15 million kilometers, and finally Jupiter within 53.7 million kilometers on March 16, 2026. For an interstellar object, these alignments were uncanny. Most extrasolar visitors cut through the solar system at random angles, missing planets by hundreds of millions of kilometers if they come close at all. Yet Atlas's path threaded the ecliptic plane almost perfectly, hitting 3 planetary encounters in sequence, each at unusually tight distances. Monte Carlo simulations put the odds of such a trajectory at less than 1 in 20,000. Analysts noted that even minor shifts in its incoming vector would have sent the object far from any planet, yet here it appeared to fly a precise survey route. The geometry didn't look random, it looked deliberate. Running the integrations backward found no prior gravitational assists that could explain the sequence. Atlas was clean, hyperbolic, arriving from Sagittarius at 58 kilometers per second, too fast to be captured, too straight to be local debris. Compared to past interstellar visitors like Oumuamua and 2I/Borisov, which cut through on more chaotic paths, Atlas's planetary choreography stood out as something bordering on impossible. The quantum AI simulations only amplified the unease. Running millions of trajectory scenarios, the system consistently flagged the Mars, Venus, Jupiter sequence as the least likely to occur naturally. In its probability cloud of outcomes, fewer than 5% suggested Atlas was a random visitor. The rest pointed toward either a derelict object on a long-set course or something actively modulating its trajectory. Controlled emissions, deliberate course corrections, and nickel-heavy exhaust patterns all pushed the odds further away from chance. The AI didn't provide words, only probabilities, but its verdict was stark. Natural explanations were thin, less than 1 in 20, while scenarios involving guidance dominated the simulations. For some researchers, that number felt less like an answer and more like a warning. The difference between a derelict relic and an active probe is vast. One is inert, the other an actor. If Atlas was steering itself, the implications could not be ignored. The unsettling part is how fragile our planetary defenses appear in light of such possibilities. In 2013, a 20-meter asteroid exploded above Chelyabinsk, Russia, with a force of 440,000 tons of TNT. It shattered windows across the city and injured over 1,600 people, and it went entirely undetected before impact. That rock was tiny compared to Atlas, which spans at least 10 kilometers, making it hundreds of times more massive. Detection systems like Atlas were built to catch near-Earth asteroids, not interstellar objects blazing in at hyperbolic speeds. If a body of this scale were on a collision course, our odds of spotting it in time to react are slim. Blind spots near the sun's glare, gaps in coverage, and the speed of incoming interstellar travelers make defense little more than a gamble. The quantum AI flagged the same vulnerability. If objects like Atlas can adjust their course, then the shield humanity relies on is more fragile than we dare admit. Every so often, an object arrives that forces civilization to reconsider its place in the cosmos. Copernicus shattered the Earth-centered universe, Galileo revealed moons orbiting Jupiter, and Apollo astronauts looked back on Earth from the lunar surface. Now, Atlas may be another such moment. Its improbable path, unnatural chemistry, and unsettling probabilities don't just hint at a new comet. They whisper of intent, of a cosmic choreography that feels anything but random. The universe may have just handed humanity another Copernican shock, a reminder that the sky is not a sealed vault, and that what moves in the dark may not always be blind chance.